Hello, everybody. Welcome to the session. Welcome to day 2 of reInvent. Really appreciate you turning out for the talk today. As the slide says, my name's Todd Golding, and I'm a partner solutions architect at AWS, and I'm part of a team called the SaaS Factory, and that team works with organizations that are in various stages of building or delivering or optimizing SaaS solutions on top of AWS. And over the last few years, if you've paid attention to our team, we've been producing a fair amount of content around prescriptive best practices on how to address all kinds of multi-tenant problems on top of the AWS stack. So identity, we've given you lots of resources about how to do identity, how to do isolation, how to do data partitioning with different services. But the feedback we've also had is, that's great, we sort of have these pockets of sort of solutions that solve specific problems, but can you show us more end-to-end solutions? Can you show us entire working solutions that sort of give us a prescriptive experience and show us what it means to connect all the dots of identity and isolation and all these bits inside of a specific stack, and with the idea that that would give us a better idea of what it means to bring all of this to life. And so our team set out to build this year a few reference architectures. We've built a serverless SaaS reference architecture. In fact, there's a session on that and a workshop on that at reInvent if you're interested. And we also built an EKS reference architecture that also has a corresponding workshop here at reInvent if you're interested in kind of digging into the weeds. And I'll, in fact, share a link for you for that at the end so that you can go clone that repo and dig into the bits of that. But the point of our session today is really to look inside that reference architecture and give you a sense of what it's doing under the hood, with the idea that if we kind of walk the landscape of all of that, you'll have a much better sense of what's there, what decisions were made about that architecture, which design principles were applied, what things we had to consider as part of building it, and then you can go away, clone it, and then start sort of figuring out how or if that might work for you in your own environment. Now, one really important point is this is a reference architecture. It is not meant to be the reference architecture, which means yes, this is an example of an implementation of SaaS on EKS, but there are lots of ways to build SaaS on EKS. Some of the things that are in this solution will probably common to lots of the solutions. Some of the choices we made might look different when we build another reference architecture or a variation of this reference architecture. So don't take this as this is the absolute one and only way to build SaaS on EKS, but I think you'll get a lot out of what's here. The other thing I would say is this is a 400 level session. So we're not going to just talk about what the fundamentals of SaaS are and what it means to be SaaS or what multi-tenancy is. And we're not going to really talk about what EKS is either, right? We're not going to sort of dig into the fundamentals and teach the fundamentals of EKS. The whole point of this session is to really get specifically into this reference architecture and even get down to the code level a little bit and let you show you a little bit of what's going on in the code. We're not going to crack open the IDE or anything, but I'm going to throw some code up on the screen. And ideally, when you're all done with that, you'll hopefully see kind of what the big moving parts of this are and what the decisions we made in our design were. Hopefully that's what you came here for. Hopefully that aligns with what you want to get out of this. If it doesn't, totally understand if you want to find another session. Now, before we dig into the architecture, though, we do want to at least quickly touch on some of the higher level principles that shaped our approach here. And the first one is why EKS? Why even build SaaS on EKS? And certainly I'm not here to say that EKS is the only place to deliver SaaS. Like I said, we have a serverless SaaS bit out there. Between serverless and EKS, which one's better? There is no better. It kind of depends on what you're trying to do, where you're coming from, lots of factors involved in choosing between those two. At the same time, EKS is a really good fit, and Kubernetes in general is a really good fit for SaaS environments. And why is that? Well, certainly in SaaS environments where we have these multi-tenant environments, where there's lots of variation activity, new tenants coming in all the time, it's really hard to sort of figure out how to scale those environments and how to really optimize those environments, the performance and the efficiency of those environments. And the rapid scaling footprint of container-based environments just fit that really well. Right now, compute can come and go at a rapid pace and really sort of keep up with those variations that are happening in our multi-tenant environments. We certainly have all the AWS security constructs that are part of this experience, but we also get new security constructs that come with the Kubernetes environment that let us do new things in terms of describing how we isolate tenants, and how we protect our SaaS environments. We'll also see just generally that Kubernetes tends to offer us a little more cost efficiency than some other variations. Serverless does really good here as well. But the idea that we're rapidly scaling here often means that the activity of our tenants and the consumption of our infrastructure is often well aligned with the actual activity of tenants, right? So the sort of amount of infrastructure being consumed, the cost of that infrastructure aligns well to the actual tenant activity of our system. The other piece here is the community tooling is just really rich here, right? And those of you that are familiar with Kubernetes, you just see new things are always being introduced, new capabilities are being introduced. And we believe that as a SaaS provider, we're going to see more and more solutions that help you build multi-tenant solutions coming out of that community effort. And so I think you'll get more options. I would like to think next year there might be new tools and new mechanisms available that have come out of the community that will let us do new things. And the last one, and I confess this is a little bit of my own bias, I feel like the developer experience can be a little bit easier here in the Kubernetes environment. If you're already a Java developer, a C# developer, or Python, or whatever you are, if you're moving into this environment, you're not being asked to rethink how you write code or anything else. Yes, writing modernized code, writing multi-tenant code means there are things you're going to have to think about, but those are just things you'd have to think about in any stack that you were going to. But here, generally, you can sort of move the mental model of how you code into these environments and have it be pretty effective. The other thing here is, what were some of the sort of key architectural considerations we had that were part of sort of this EKS story? Like, okay, you're building on EKS. How did EKS shape some of the architecture choices you made? Where did you have to do something potentially unique because you were in an EKS environment? And what we find here is that certainly the deployment models we wanted to support and the different ways that we wanted to package and deliver this environment. So for example, I want some tenants to have fully siloed environments where they have dedicated resources just for a given tenant. And I want other environments where I want to be able to, not environments really, other deployments where I want to be able to have those resources shared by tenants. And how do I put those things side by side? And should those be in clusters? Should those be in namespaces? What Kubernetes constructs best support those deployment models? That's a big part of the thought process that went into this model, and an area where we're enriching the solution as we speak. In fact, if you go to the workshop, you'll see we did a lot more with new deployment models there that are going to find their way into this reference architecture. Routing, believe it or not, routing, like, why should routing be a big deal? Routing's just routing. Well, it turns out as we deploy tenants into these different configurations, namespaces, clusters, whatever, we have to figure out how, when traffic comes in a tenant context, how does it come in and get routed appropriately to the right area in our cluster where our tenant resources are actually running. And there was a lot of discussion actually here in EKS about what we would do. Certainly the automation and the configuration and the deployment of tenant environments looks different in EKS. The tools are different here. How I describe the deployment configuration of your environment, how your microservices are deployed, how the automation of all that uses kubectl and all these other tools we now have available to us in the EKS stack. And so the experience here is different than, say, serverless or EC2 or somewhere else, because the tool chain is different here. And then isolation. Isolation is part of every single SaaS talk. But now that we're running in this Kubernetes clusters, what are we really going to do to isolate tenants? What are the new isolation constructs we have available to us? And you'll see as we get to isolation, there are very specific Kubernetes things we did here to isolate our tenant resources. And then the last one, certainly, how are we going to offer a tiered experience to our tenants? How are we going to make it so that a basic tier tenant potentially gets a different experience than a platinum tier tenant? And what knobs and dials does EKS give to me to make that possible? So these are just kind of, this isn't everything we thought about, but this is kind of maybe the top five sort of, it is five, yes, top five things here that sort of stood out to me as things we talked about a lot when we were building the EKS architecture. Okay, enough sort of like setting the table and why and conceptual bits. Let's actually get into the architecture and start talking about what it is. And we'll start here at a conceptual view just so you get a high-level view of what this thing does, right? And so if you look at this, you'll see a series of applications that we've introduced to try to just emulate what a typical SaaS environment would need. So we have this landing page that you'll get in this application that is really just a sign-up page. And we wanted to show you what a self-service onboarding experience would look like. So this landing page essentially lets somebody sign up, onboard into your environment. But we also have, and you'll see in this separate admin console, a model where somebody can internally provision a tenant as well. So we're trying to show you both halves of that equation, one where it's fully self-service and one where it's an internally driven process. And the whole point of that is to drive home the idea that no matter which channel they come through onboarding, that should be a fully automated, frictionless experience. Sometimes people think when it's an internal process that it's somehow different. It isn't. We still want to use the same sort of principles there. So tenants come in, they get here, they sign up, and then we'll show you a sample SaaS application. And this SaaS application is not exotic. It's not all that interesting. We only put a few microservices in here. The whole point of introducing this, though, is there's lots more going on in that application around authentication and how we route to the services and all those other bits that we think would be interesting to you in terms of taking away and figuring out what you might have to do at the application side of this. But the actual features and functions of this application is just a little commerce thing with a couple of microservices, nothing exotic there. But hopefully there's enough there to show you what you might have to do in your own application. Obviously, this application has to authenticate into our environment, so it uses Cognito, and we'll dig into that authentication experience. And then we have an admin console. The application most SaaS teams don't have, is what I find, or they use some sort of mix of tools that are third-party tools here. But we actually have an admin dashboard that is an admin dashboard for managing tenants, and it is the single pane of glass to look across all the activity of your tenants, what they're doing, configure their environment, and so on. And obviously, and by the way, that's the experience of you as a SaaS provider in that particular role. And those users have to authenticate in, and they also authenticate into Cognito. And then, of course, all of these applications are interacting with EKS on the back end. And the simple view of this is that the services that are running in here are broken into two categories. We have a control plane. The control plane is essentially where all the shared services of our application run. These are the services that aren't about your business functionality. They're about onboarding tenants. They're about identity. They're about managing tenants. They're all these horizontal bits. And in fact, these are the pieces, sometimes this control plane piece doesn't get built out fully. You will hear from our team lots more around like what should be in that control plane if you start looking more and more at patterns. Now, we haven't built out a fully implemented control plane here in that we haven't included billing or metrics and a lot of the other things you will see. They'll get added in here. Some of those are actually in our serverless SaaS solution, but a fully implemented control plane would have all those bits. But we've got lots of the pieces that are a good starting point here. And then the other half of this is the application plane. The application plane is where the actual SaaS application code is running here. So here you'll see microservices, you'll see tenant isolation, you'll see data partitioning, you'll see all the things that our application microservices have to deal with. Now this is super high level, looks super simple, but when we dig into it here, you'll see there's a lot more going on. So let's start by looking at, well, okay, I download this repo, I provision it, I install it, and get it all set up. What actually gets initially provisioned? And this is where you'll see the control plane architecture. All of that just needs to get provisioned and set up for you from the beginning. And we provision this into a classic, well-architected AWS model of multi-AZ, high availability sort of model, the things you see across 100 presentations here at reInvent. We'll have a public subnet as the entry point to this. And we'll have this ingress controller. And we'll come back to this ingress controller because it gets into that whole routing discussion of how we do contextual routing for tenants. But just know that that's sort of a placeholder for the moment. And then back in the private subnet of our environment, this is where our actual shared services of our control plane are going to run. And they're running in an EKS cluster. And in that EKS cluster, then we'll create this registration service that orchestrates all the onboarding of our tenants, and it has a lot of moving parts to it. Tenant management deals with all the tenant policies, the identity configuration, all those other bits of getting tenants in, and user management, which is just basic management of users and configuration users and management of their identity. Nothing super exotic here. And again, like if you look like a full control plane, there'd probably be about 5 or 6 more services in this box. But these are absolutely enough services to give you a good starting point. Now, if we look at the actual provisioning of this, right, you go get the repo and say, awesome, what actually gets provision behind the scenes, what's going on when I run the scripts that set all that stuff up, you'll see that there's a lot more actually being created than just what's on that simple diagram. So if you go look at the CloudFormation templates that are part of this, they're broken into a couple of categories. There's this base template, which is essentially provisioning just a hodgepodge of things that are needed. There's a certificate. We did SSL here. We do subdomains you're going to see here. That's a hard part of this, and so we did this in this EKS architecture. In fact, this is the only place in any of our solutions that we've really shown certificates and subdomains as part of an experience, and it added a lot of complexity to this experience. You'll see that we provision a tenant table because there's only one tenant table for the whole system. We'll provision it now at the beginning because that's going to be used to hold our tenants. And then we set up some custom resources for CloudFormation and this whole notion of the hosted zone that gets all into our certificate processing. And then you'll see templates for each of those three applications I mentioned, the landing site, the app site, the admin site, and you'll see all the classic things you need to do to get a single page application running in an AWS environment, right? I need CloudFront, I need bucket policies, I need a cloud distro. So each one of those resources in that left-hand column of that are actually performed 3 times, once for each of those applications that you see across the top. And then we also have to provision the bits for the SaaS admin provider here to get in that first user that is in your SaaS admin console. So you'll see that we create an app client in Cognito, and we create that first admin user. So after you're done, if you could go log into the admin console, you'll get an email for who that the admin user you used to sign up. And now you can go in and start provisioning tenants and so on through the admin console. We also have to set up the repositories for the microservices that are part of this experience. So the control plane services, registration, et cetera, the app plane services, we have to set up those repositories that are going to be part of this experience. And then the last bit is we have to set up some tables and some resources that are needed for our onboarding experience, including, you'll see the product table here. The product table gets created here at the beginning. It's one of our microservices, but it's a pooled, shared by all tenants resource, so we can provision it up front here because we're only going to need one of those no matter how many tenants we introduce into the system. And then some of the code commit bits, and we'll get into that. Okay, another real simple thing here, we're obviously managing tenants and users in this space, and there's nothing exotic going on here. Our admin console, when you get in, can go in, it hits this tenant management service, and here's where you can configure and update and manage the states of tenants. Nothing super crazy going on there. Stores a lot of that data there. We'll find out that that tenant management service is holding interesting data, though, that is used for authentication and other roles here. And then we have this user management service, and right now we're sharing that user management service between the admin and the SaaS application. So admin users, I can create them and disable them and manage their lifecycle there, and actual tenant users can be managed through this experience as well, and that's all managing context on top of Cognito. Nothing exotic there. Now, here's where things get a little more interesting. So now we want to onboard a new tenant to this environment. And we have to, there's actually lots of moving parts to getting a tenant introduced to our environment. So if we walk the flow of this, a tenant comes in, they hit that landing page. If you remember, that landing page we talked about is the self-service onboarding. Could come through another path, but I'm showing the self-service path right now. I fill out the data about my tenant, provide information about who they are, et cetera, including what plan they're signing up for, basic, advanced, platinum, whatever sort of tier they are. And then this passes that data into the registration service that we saw in our control plane earlier. And it's the job of this registration service to orchestrate everything that's needed to get all the resources created to introduce this new tenant environment. And then the simple parts of that are the ones we've kind of already talked about. I need to go get a user created, so it goes out to the user management service, and it says, hey, what am I going to need to get to create this new user in the system? Well, I'm going to create a separate user pool for each tenant. There's always some discussion of could you use one user pool, and there's lots of guidance we give on when you might use a separate user pool versus one user pool. In this particular example, we're using a user pool per tenant. In our serverless one, we have an entirely different approach to the user pools just to show variety. The app ID is here as part that's needed as part of the onboard, sort of the authentication experience. And then custom claims. If you're used to OIDC as like an authentication mechanism here, when you come in, you'll see that we actually need to embed tenant attributes in our identity here. So your tenant ID, your role, everything we need for tenant context gets pushed into those authentication into those custom claims. And when we authenticate and come back, which we'll see later on, the token that comes out of that now has that custom claims. And so when we authenticate, we don't just get who you are as a user, we get your tenant context attached to you. And that becomes critical to isolation and data partitioning and everything else down the stream. So nothing complicated about it, but a super important piece of the puzzle in terms of the other bits we're going to look at. Tenant management, like I said, just going to put basic information out here, including identity settings. So how am I mapping a given user to a given user pool? So when they come in and authenticate, how am I going to authenticate them? And we'll look at that. But those two services aren't crazy hard, and you'll probably crack those open and they'll be easy. Where things get a little more interesting is when we say, yeah, that's great, but now inside the EKS cluster that we're about to create, what do we have to do inside there? What are all the resources we have to configure? What do we have to do to get all the routing to work? What are all the per tenant resources that have to happen when I onboard here? And it turns out there's a fair amount of work here. In fact, I would say this is where you start to blur the DevOps line here a little bit, right? We're all used to the notion of CI/CD and DevOps and this idea that we have tooling that provisions our environment, configures it, and deploys it. But in this case, as new tenants are coming in, as they're registering and signing up for our system, we are running all of this code pipeline, all of this infrastructure's code bits that's happening each time a tenant comes in. Well, I think that's my DevOps code, but it's not running as part of a traditional sort of just build, test, release kind of process. Now it's happening and being triggered by the registration process. And we'll dig into that. I would say, 50% of this talk is about what's going on inside that provisioning bit, because that's where a lot of the EKS goodness actually happens. Now, if we look inside the tenant registration service, this code's written in Java. The new version of this is a TypeScript version of this. We never seem to be able to pick a language that makes everybody happy. But the key here is to get the concepts right. But you will see a TypeScript version of this. In fact, the workshop that's part of this is actually got all the new TypeScript bits in it. So if you want to go see that as a sneak peek of what's coming, that's a possibility. So pretty straightforward register tenant function here. And you'll see the steps here inside the code that are basically the steps we were just talking about. Create the tenant, create the user, and then you'll see this create tenant service, which seems pretty basic, but really create tenant services is that whole go provision everything in EKS. That's where 90% of the effort in this provisioning process happens. So if we just look at the create the tenant piece to look at an example of what's going on there, you'll see, yes, we hit the tenant. It's classic REST-y kind of stuff going on here. I get the URL for the endpoint for the tenant management service, and I go out and I take the tenant details and I do a post to that. And it's just like any other sort of REST-y sort of service that we'd write. Nothing super crazy or exotic going on there. But now when we get into that creating tenant services flow, things get a little tricky. And this is where hopefully I'll weave this together in a way that the dots will connect for you, but if they do connect, it will make it much easier for you to navigate the repo and know what's going on when you go to get the reference architecture. So hopefully this is, well, good luck. Hopefully you can read it. We'll see if I put too much, if it's too fine print. But the basic flow here is that we have this tenant stack that is a CloudFormation stack that has the configuration steps that are going to be run to provision all the infrastructure, configure Kubernetes, do all those good bits that need to happen to get each tenant environment set up. But this tenant stack is actually not in the repo when you start. It's actually generated as part of the overall process because it relies on other references to infrastructure that aren't available when you first get the repo. And we'll look at what happens there. But either way, this tenant stack ultimately is the stack that's going to be run, that's going to trigger all the moving parts of getting a tenant provisioned. So then you'll see that it needs certain parameters like any CloudFormation stack does. So we give it the tenant ID, we give it the domain information because it needs that information to provision the resources that are needed. And then we give it the URI for the microservice for the product service, and we give it the URI for the order service. All right, and then we run off and run create stack. And at that point, you're like, that's easy. I run the stack, and it takes those parameters, and we're all done. Well, there's a lot more kind of going on under the hood of that. Like, where did I deploy the microservices? Where did I create the namespaces? Where did I do all the other things that have to happen here? And this is where we have to connect the dots a little bit.
So if we go look at the actual repo, you will see there's this update provisioning, let me get it right, update tenant provisioning stack script that's out there that was run as part of the setup of your environment. And you'll see here, it goes and gets the cluster, the VPC, it goes and gets this data that it could only get after the environment was provisioned, and it pushes those parameters into our tenant stack, that generated stack that we talked about. And now in that generated stack, when we're running that tenant stack, what you're gonna find here is, so we have registration called create tenant services, and then that ran this tenant stack CloudFormation bits, and then within that CloudFormation, there is the run of a code build project. And that code build project, like all code build project, references a build spec YAML. And the build spec YAML is actually where 90% of what's going on here in terms of setting up your EKS sort of environment here. So a little convoluted path to get there, but hopefully you can see we take that tenant stack that's generated, we populate it with the right parameters that it needed, including the generated ones, VPCs and so on, and then when we run that stack, some things are going in that stack that are just provisioning resources, but a big piece of this is this code build that fires off and references this build spec YAML. So if you just go jump into the build spec YAML, you'll see all this cool stuff going on, but you may not know how it's getting invoked. So I wanted to sort of connect those dots for you. But let's now step back from that build spec YAML for a second and say, okay, awesome, you're talking about all this stuff that's gonna get configured in our tenant environment. What's actually gonna get configured in there? So if you now take our same architecture, the same environment we created, this multi-AZ environment, we're now gonna provision application plane resources into that environment. And here's where we had lots of choices. Like, what do you do here? I could do a cluster for each tenant. I could have, hey, we're gonna do siloed model because we feel like that's the right model for our customers, and we'll create a separate cluster for each tenant. Perfectly valid model. Another option we have is to do a separate namespace for each tenant. Now we're inside a cluster and we're using the Kubernetes sort of namespace construct as our silo boundary. Or we could have just said, put them all in here as pooled. And we're just gonna know that we can't do great isolation between them, but we've chosen to do pool. Now for this solution I'm gonna show you, we chose namespace. We thought it was a good practice, but there's plenty of discussion to be had around this in terms of what the right approach is, and we just wanna probe that more if we were having a conversation about it. I will tell you that the new version of this that's coming and the one that's in the workshop actually runs pool and it runs silos side by side. So it has namespaces for siloed customers who are platinum tier, and it has basic tier tenants running in a pooled model side by side. So we show you what it means to have both of those there and deal with all the routing that's there. The other thing here is we right now put all this in one cluster. We could have put the control plane in one cluster and the app plane in a separate cluster, and we are revisiting whether we might want to do that. Right now the control plane's just in another namespace. I believe it's in the default namespace, but don't quote me on that. Anyway, so now when tenants come in and they get provisioned, we essentially are going to provision a namespace for each tenant. And this is what that build spec YAML is going to do. It's going to provision and configure all this, and it's going to deploy the microservices. So we have an order service and a product service. You saw earlier we created the order table because, we created the product table because, and then you'll see that we have to actually provision other resources. I show order and product here, but there's more happening here than just deploying and configuring these bits. Next tenant comes along, create another namespace, right? And so this build spec YAMLs, that's job all day long, is to provision all that infrastructure. And essentially when we're done and this is all running, now when we want to deploy like a new version of the order service, it actually has to get deployed to each one of these namespaces as well, right? So our deployment of just functionality and features changes based on this experience as well. Now if we look a little more at the namespace provisioning, right, imagine we have a cluster, we have these two tenants out here in this namespace. Our ingress controller is routing successfully. We'll again talk about that in a moment in terms of how that's working. And now we're introducing this new tenant. Our registration hits this code pipeline that we talked about in that process earlier, and it invokes this build spec YAML. And this build spec YAML creates the namespace, creates IAM roles, and it deploys the services and containers. And then it also references a separate YAML for each microservice you're deploying. So the top part of this, of the build spec YAML, you could just grab and reuse in any environment, but then for your microservices, you'd essentially go and introduce a separate YAML for each one of your microservices, and there you could configure the scaling and the attributes on a microservice by microservice basis, which is why we made the choice we made here, and we want to make it easier for you to drop in and introduce your own microservices. Now, if we look inside the tenant provisioning and we look inside that build spec YAML and we say, what's going on here inside the build spec YAML, we're going to look at this in two parts. Right now, we're just going to look at what's it mean to get the tenant resources provisioned, and then we're going to see that this build spec also has a role in isolation as well, but we'll cover it in two segments here. But in just this tenant provisioning bits, you'll see here we're using kubectl or kubectl. I can never get anybody to tell me what are the absolute name everybody agrees on for this, the tooling, but this is Kubernetes tooling to create the namespace. And then we'll create an order table, which you'd think, well, why is that here? But if you think about it, we said order is in a siloed model, so every single time we onboard a tenant, we don't just have to create their namespace, we know that they're going to need a separate order table for each tenant that's coming on. And then we're going to go out to those YAML files, those per microservice YAML files, and tell them to go essentially deploy and set up that microservice here. So you'll see the product service getting deployed here, and you'll see the order service getting deployed here. Right? So when that part of the build spec is done, we've essentially configured, set up a namespace, and obviously there's other goodness happening in the surrounding tenant stack that's going on at the CloudFormation level, but this is the core concept that's happening here. Now, if we look inside that one of those microservice YAMLs and say what's actually happening inside that microservice YAML that's being run by the build spec, now we're in the classic sort of universe of Kubernetes. This would have nothing to do with the reference architecture. Now we're just down to using the tools and the mechanisms that Kubernetes gives us to describe and deploy services. So Kubernetes has the notion of a deployment. You'll see here replicas is the number of replicas I'm deploying. This is where I could set a number of replicas specific to this service if I wanted to. And I'm telling it where the URI is for the repo. This relates to the repo we talked about earlier that we were set up. And you'll see that I have to also set up the service, right? There's actually one more moving part of this that we'll come back to, but this essentially is what you'd be configuring on a microservice by microservice basis. Now, the other piece of this is we talked about the fact that we're using subdomains, and as part of setting all this up, we also have to get the subdomain introduced into the environment. So part of this provisioning process also comes in and says, hey, I'm signing up this new tenant. They've told me their company name. We've got this name we're going to use as part of their subdomain. And now we have to go out to CloudFront, and you'll see out of the box, there's this app.sasco.com that we've created. That's the placeholder here. And now what we have to do is say our new tenant is in here. We have to introduce that tenant into CloudFront so that CloudFront can serve that specific tenant. And we'll actually use that information from the subdomain to target the needs of that specific tenant and route for that specific tenant. The other piece of this is obviously the DNS piece of this, the Route 53 piece of this. We have this app.sasco here. We have to add our tenant to this as well. So nothing super exotic or complicated here, but you can see for CloudFront and Route 53, our automated onboarding process also has to create these entries for us so that we can get our subdomain routing to work for our individual tenants. Okay, so we've provisioned the whole environment, we've onboarded a tenant, and now what does it mean to actually authenticate a tenant coming into this experience? How do all the pieces that we created work here? So we hit our sample SaaS application, we come in as a tenant, we provide the subdomain in that tenant context, and now we have to authenticate against a user pool, but we don't know what user pool to authenticate against because there's a user pool for each tenant. We know your subdomain, but that's not going to get me to the right user pool. So this is where we stuffed away in tenant management. I told you we stored some identity settings during that registration process. Here's we map the origin of the incoming to the company. Then we figure out, oh, you're tenant 1, and you're using this user pool, you're using this particular app ID, and now we have the data we need to authenticate you. So that data comes back, and you'll see just in our little tooling here in our SaaS app just to make this a little simpler for you, we use this little library to sort of store off those settings so that it can just be referenced easily. Again, this is where, even though the app isn't exotic, seeing how all this authentication works inside that app code gets useful to you. And now we're just into a typical OAuth flow. We know what Cognito user pool we want to auth against, so we hit that user pool. It gives us back a code. We exchange that code for a JOT token, and that JOT token is the secret sauce of our user identity plus our tenant context. Now when we have that magic JOT token, it flows down to our microservices as we make microservice calls. And now that microservice, as it needs to log information or access data or do something that requires tenant context, it can just crack open that JOT token, look inside of it, and get exactly what you need. Again, and then that gets into the isolation story and so on. Now routing, I said we'd look at routing. There's nothing crazy hard about routing, but I'd say routing has cost considerations. It depends on whether you're a subdomain. There's just 100 different factors that would influence what you might use as your routing mechanism. So while I'm going to say we're using Route 53 and we're coming into an Ingress controller, API gateway can work here. The Kubernetes community has lots of networking sort of constructs that can go in here. Find the one that works for you. We thought this was a good fit for our solution, but you ought to have a hard discussion about what's the right fit for you. In this model where we're using the Ingress controller, essentially, we have to create routes for each one of our microservices. We create an Ingress resource in each microservice in each namespace, and as each tenant onboards, we actually have to configure this route so that when we come through, the route actually gets you to the appropriate microservice with the appropriate context. And how does that work? Well, I said there was a second part to our YAML file, right? We had order service that had our deployment and our service in it. There's more to that experience, which is the configuration of these Ingress routes. So here you'll see tenant one's coming in. I'm setting up the order route and configuring those bits. So back over in that build spec, when we referenced each microservice YAML, one of the things you're going to see in that each microservice YAML is the configuration of these Ingress routes as well. And that creates Ingress resource, makes all that routing work. Okay, now tenant isolation, right? We've got this great running environment. Tenants can get in, they can authenticate into it. And every time we build a SaaS solution, we have to ask ourselves, like, what are we going to do to make sure one tenant can't get to another tenant's resources? How do we protect them? And what does EKS specifically let us do to potentially protect that? And what you're going to see here is a blend of the classic things we would do to provide isolation and some specific areas where we leaned on EKS to implement our isolation. But let's look at the basic problem, right? We have these namespaces, they're running these tenants. We've got this data. We've got an order table for each tenant that's out there that's running. And we've got this product table that's out there that's shared by tenants. And now we have to look at, well, where are all the places we have to think about isolation? Well, we certainly want to be sure that we can't cross namespace boundaries and cross compute. So some microservice in tenant 1 namespace shouldn't be accessing tenant 2 namespace data, right? And we also have to think about as we go out and access other resources. It's data here, but it could be queues, it could be Elasticsearch, it could be any number of resources. As I leave the compute to go out and access another resource, how do I ensure that somebody running in the tenant 2 namespace isn't going and accessing the order table for tenant 1? Like, what's there? There's nothing to guarantee you that somebody can't cross that boundary other than well-behaved code, and we know that code isn't always well-behaved. Anyway, so what do we do here? Well, let's start at the outer level list. Let's look at this more coarse-grained way to apply the isolation in here. So if we look at a namespace and we look at our order service specifically, these namespaces have a service account here associated with them. And we know that order table is a table per tenant. It's running in a silo model. And because it's running in that model, we can actually go out and define a policy that says, hey, for the service account for tenant 1 namespace, make sure that the services running in here can only access the tenant 1 order table. They cannot go to anywhere else. And because we attach this at the service account level, you can't now get out and do anything in the code. It wouldn't matter because it's sort of applied globally to the code running in this service account. And the same thing happens for tenant 2. We just attach another policy there. So here, it's sort of all done for you. The isolation is all done for you. And if you go look at the policy that defines this, it's not a super exotic policy. You'll see that we essentially, you'll see on line 8 here of the code, there's a tenant name sort of holder there. That's where we substitute in the information to give the context of individual tenants. And that will restrict your access to the order table that's done here. Now, just to give you a sense of the code, and I'm going to show you code and then say there's not much to this code, but it is to make a point, which is if we dig into the code that's behind this where we're going out and getting an order, it's going to look exactly like you would expect it would. We're going to go get the tenant ID. We're going to call some order service saying, go get me an order by ID. And then if we dig into that, we'll see, oh, there's this place where we go and look up the order table's name. So we order dash as the prefix of the table, and we'll append the appropriate amount onto the end of this. That resolves this to this tenant's name, and we'll go call this load function, and it'll go get the data and return it back to the tenant. So why did you show me this? Well, my point is there's no code in here that's enforcing isolation at all. There's nothing we added. There's no special, and if you looked at other code we have where we don't have service account isolation, you'd actually see code here where you're relying on your developer to go resolve the context and apply the policy and essentially ensure that somebody can't cross the boundary. But because we attach this policy at the service account level, we can sort of trust that we can just go write this code as we would normally write it and rely on that policy to restrict our access. So for me, it's all about cleaning up the code, and any chance I get having code where the developer doesn't think about multi-tenancy when they're writing code, they just do what they naturally would do. Now, this gets a little more challenging when we look at the pool model, right? We have this product table. The product table is shared by tenants. Well, we can't use a service account here kind of construct because the product service running in namespace 1 and the product service running in namespace 2 both need to access that same table. So that more coarse-grained way, that service account way of implementing isolation is gone for us. So now you fall back to the sort of mechanisms you'll see across all of our solutions, which is I would call that runtime enforced isolation. Now the code inside of these services has to, at runtime, hopefully with libraries and other mechanisms you've put in place to make this simpler, go out and resolve the credentials that will be used to access the data in the context of a given tenant. So here you'll see there's a policy here, and you'll see that it is going out, and really it's attached to tenant 2, but I show tenant 1 in the box, so maybe that's a little off there. But the idea here is that this microservice will go out. It will look at the policy in the context of the current request it's processing. It will apply the policy that is appropriate for that tenant, get credentials back. It'll assume a role here, essentially, if you're familiar with IAM. And that now those credentials will be used as I go to access that table. And because it's at the item level, it will ensure that I can only access resources that belong to that specific tenant. So very different than what we did at the service account level. This, I would say, is not an EKS-specific sort of concept. If you've looked at our content, you'll see this example across a whole bunch of what we've done. We do have this thing called a token vending machine out. It's one more of our little projects out there. If you haven't taken a look at the token vending machine, it implements all the moving parts of being able to go out and assume the role and implement your policy. The idea is we wanted to give you a library, essentially, that you could just put alongside your code here, call it, go define your policies, and this would all just work. So you'll inevitably need this, but ideally, if you could be more coarse-grained there, it'd be a good idea. Now, what do we do to actually isolate the namespaces, right? That took care of the data piece of this, but what do we actually do to isolate the namespaces? And here we have tenant namespace 1, tenant namespace 2. I want to ensure that you can't cross the boundary here. So what I have to do is actually have a policy here that I introduce as well that lets me restrict that boundary as well. So here, as I go into this, you'll see here's a sample policy. Again, tenant underscore name is here as a placeholder. This is where we'd substitute the tenant context into this experience, and now that prevents tenant boundaries. So to me, one of the really exciting parts about EKS and Kubernetes, and in general, the container space is there are lots of interesting tools that are helpful for isolation, right? There are lots of tools that will let you put sidecars and other mechanisms around your containers and your code that can intercept activity and enforce isolation on your behalf. So I feel like this is an area we're going to continue to look for new and better ways to use EKS primitives to be able to go out and essentially say, hey, we're gonna monitor and enforce isolation in a way that is entirely outside of your view, and then developers don't have to have any awareness. They don't have to do the token vending machine. And I feel like the Kubernetes environment gives us lots of constructs for us to sort of innovate there and come up with clever ideas. People are already sort of playing with stuff in this space quite a bit, and a number of partner solutions in that sidecar sort of space around security where I think we might be able to pick that up and use it. So if we look at the actual build spec again, I told you earlier we had the build spec, and the build spec had part 1 to it, where we actually looked at how do we configure the namespaces, how do we deploy the namespaces, how do we deploy the code. Well, the other code that's inside that build spec is actually configuring these isolation bits as well. So when we dig in here, you'll see we create a policy for accessing DynamoDB. This is that service account policy that's happening here. So for that table that we create, we also now create this policy that is the service account policy. We will also then go apply that policy using the EKSCuttle command. And then the last step here is to apply that policy that sort of prevents our cross-tenant access across the namespaces. So when you're all done here and you go open up build spec YAML, you're going to see both the isolation story inside that build spec YAML, and you're going to see all that provisioning bits inside that build spec YAML. Now, I always want to emphasize that no matter what we're building in terms of EKS or serverless or whatever, that it's always super important to me that if you're going to build a really good solution, that you ought to make a microservice developer's experience as simple as possible. And we kind of talked about that as we looked at the code for get order by ID and how we want that to be as seamless and frictionless as possible for them. So here, as I'm developing a microservice, and I'm in here writing the logic and the business functionality for that microservice, and I need to do something that requires tenant context. I want to log something, right? Something simple as log a message. Well, logs need tenant context in a multi-tenant environment. We don't want to just have everybody logging. We want them logging with tenant context so that when we go into our admin console and our tooling that is going to go try to troubleshoot some problem on behalf of an individual tenant, we want to be able to filter all those logs based on the actual tenant context. We often want tier in there as well and other data in there that will let us filter and analyze the trends of our tenants. So here with the log manager will go out and get a JOT token. Here's another thing we've introduced, this token manager. It was actually in a screenshot earlier, but we didn't talk about it much. So we've taken all the work of unpacking a JOT token, because there's some work to be done there. And when you get that JOT token, it's signed, and what do you do to get it unpacked so it can get to that tenant context? Well, we don't want developers doing that, so we put that into a library. And now we can log a message with tenant context, and the log manager just takes care of resolving all that tenant context. So I just take the incoming request, it goes to the log manager, resolves it, and you're all done. Or if I need to go access data and I need tenant context, I can just ask the token manager for the tenant ID, give it for me, and now as I'm going out and trying to figure out, is this a silo, is it a pool, how do I use tenant context to decide how I'm accessing the data, I can use that tenant context there. And we actually have lots of examples around metrics and analytics and all kinds of other places where you'll see us trying to build more and more libraries that are reusable libraries that move multi-tenant awareness away from developers. So we show you how to do some of this in EKS. We need to show you more. We're still not showing you what all the ways that you could do this, but it's still super important piece just in general if you're trying to build a good SaaS environment and have a good development experience. So if you look at this example, here's that token manager I talked about. So now whenever I need a tenant ID inside my code, I just reference that token manager, and whenever I want to log a message, I just log the message, and it just works, and I don't have to think about what it means to inject all that tenant context. The other thing, and this is an area that I feel like is a growth area for our reference architecture, and one that if we had more time, I think we would do more with, but one I think you ought to care about, is how do I offer different experiences to different tier tenants? And this is where Kubernetes gives us really interesting ways to do this, and one of them is through resource quotas. So I can really attach resource quotas to my namespaces and then say, hey, my basic tier tenant is going to have this resource quota and scaling configuration, whereas my, my advanced tier tenant will have a different configuration. And then the last thing I kind of want to touch on here is we feel like there's lots of tools and cool sort of mechanisms that are out there in the community. Somebody has come along, this isn't published yet, but introduced KubeCost. If anybody's familiar with KubeCost, it lets you actually see sort of, we can break down and see cost-related consumption activity on a per-tenant basis, which is something we've been advocating that people do all along, which is, I don't want to know just how my tenants are using the system. I'd like to correlate that to cost. KubeCost gives me a way to try to do that. And so I'd like to see this show up. So I include this here as a hopeful moment of hopefully we'll get this in. At a minimum, though, I would encourage you to start thinking about, like if I was going to go use this, I would include KubeCost on my sort of list of things I would want to pull in potentially. Okay, so what are some of the takeaways from this session? Well, hopefully you can, it's maybe not super obvious, but we try to make the point that, like the footprint of EKS, the operational model, the efficiency model, the tooling of EKS really give us good opportunities in a SaaS environment. They are a good fit for that experience. So I think this is why we see lots of SaaS organizations seeing EKS as a compelling home for their solutions. And then this notion of deployment models. We talked about silo and pool, but we didn't really get into that a ton. But this silo and pool, when you go away, it's going to be a huge part of your discussion in terms of what are you really going to do in the EKS architecture of your solution? Are you going to have a cluster per tenant, namespace per tenant? Are you going to run everybody in a pool? Or are you going to support both? Like, it's kind of up to you, but it's going to have a big influence on what's in that build spec YAML. It's going to have a big influence on that provisioning experience and the isolation experience. And obviously, you know, expect to support a mix of models. Most people we see aren't exclusively silo or exclusively pool. They are often supporting that. And in fact, then you got to think about what it means to move between tiers. And then routing is one that I think I tried to make this point clear that routing is an area that warrants a fair amount of discussion. The Ingress controller is a good solution here, but go out there and look at the resources that are out there around the routing here. Figure out if you're a subdomain, whatever you are, and figure out which one of those is best for your particular environment. Think about cost as part of that as well. And then this last bit we had around service quotas, so on. Like, don't leave tiering out of the equation. Think about tiering all the way through to how you want load placed on your environment. Like, you should be potentially restricting the load that basic tier or freemium tier tenant can put on your environment. How are you going to do that? What are the mechanisms that are available to you to do that? Isolate, just isolate no matter what. Tenant isolation isn't a deployment model, by the way. Sometimes people think because I deploy something in a silo, I'm done with isolation. No, I can deploy something in a silo model, but if I haven't put a layer of isolation on top of that restricts access, somebody can still cross a tenant boundary. So don't equate silo to isolation. Instead, look at isolation as the layer of whatever's on top of however you built your system that is going to enforce all the isolation policies that are part of your environment. And we saw network level isolation between namespaces. We also saw resource level isolation like order tables and the product table and so on. I'd also say, like, try to build these shared libraries, right? And I don't have a good word here because it depends on your language stack. Is it assembly? Is it a jar? Or is it a module or whatever it is? Go build those libraries of reusable concepts for logging and metrics and analytics, and try to take all the heavy lifting of multi-tenancy off the back of your users. And then the last one here, lean on the Kubernetes community, right? Like, stay engaged with that community, see what tooling's going on out there, pay attention to what multi-tenant things are emerging, because those could be valuable for you. Okay, I promised a couple of links here that at the end, here's the link to the reference architecture itself. that's out there. And then there's the link to the workshop. So if you want to go look at what that workshop's all about, definitely encourage you to try to attend it. I don't know how turnout has been. I know the registration's been pretty full for it, but there may be room to squeeze into the sessions that. There's 2 sessions of that are running. I think one is running this afternoon. I'm not positive. I got to go back and look at the schedule. And I would tell you there's a corresponding serverless version of this. So if you're on the fence and thinking about EKS or serverless or what should I do, you could go look at the serverless version of this as well and see what's there. Some people are doing a mix of EKS and serverless as well. Like some services are running serverless, some are running EKS. And we haven't really thought about whether or not we should show some reference around what that might look like. But I would definitely encourage you to look at that. And then there's just a number of sessions going on around SaaS here at reInvent. There's migration talks, there are business talks, there's a discussion of SaaS Boost. I don't know if any of you have heard of SaaS Boost, but SaaS Boost is another open source tool we have that is a tooling where we're trying to build an entire experience around this that will essentially give you the tooling that can create an EKS environment, create a serverless environment through YAML and CDK and a lot of new tools and mechanisms that we'll make available to there. I would encourage you to check that session out if you're interested in that. And that's it. I really appreciate you coming. Hope you have a great reInvent. And please fill out your surveys. I appreciate that. Have a good reInvent.